So this is the first robot I ever made. I made it a few months ago for a class, or as a part of a class. And I want to point out a few things about it. One, it is a social robot in that it's supposed to, mimic certain aspects of a human face. But you can't really think of it in terms of, like a sci-fi robot. It's not going to talk to you, it's not going to answer questions, things like that. But because it has a completely different purpose. The purpose of this robot is to really be sort of a learning platform, and also a platform that sort of inspires innovation. So I want to point out a few things. All of these plastic parts are 3D printed out of PLA. Now this was the first time I had ever used a 3D printer, so that whole process was incredibly valuable to me, just to learn how to take a file and turn it into an actual three-dimensional printed object. Um, it has 16 servo motors that run the various parts, these little guys, and then it has three of these larger servo motors. Again, I knew what a servo motor was, but I had never worked with one before. So learning how all of that works was incredibly valuable to me. The other thing I want to point out is sort of figuring out the physical connections between the servo motors and the moving parts. There was quite a lot of innovation and thinking that engineering that had to go along with this. So for example, if you can see this brass Y piece in here, the original design did not have this. It had a very different mechanism for connecting the motors to the eyelids. And I sort of, frankly, by accident came up with this design after trying to find a much better way to do it. So the reason that that's important is because this was not just a thought experiment. This was not just on paper. This piece, which seems simple now that you see it, came out of trying different things, some more successful than others. And that really is part of the whole point of this project, because when you actually sit down to do the design, especially if the design is not sort of a perfect Legos, complete thing, you do have to figure out how to overcome various problems. And that is tremendously valuable as far as a learning process. The other thing that's been really great about this is that because of this build experience, I've been able to go on and build other things that were much more complicated and much more sort of innovative, less obvious designs. But it all was because I had the practical experience of building something like this. So let me just point out some of the features here. So these servo motors down here affect the tilt of the head, which is on a universal joint here. There's a servo motor underneath that can rotate the neck. As I said before, the eyelids are articulated. Now, you're probably not going to see them move in this demo because this robot has been used for a couple of demonstrations and some of the parts have broken. So, for example, the thing that actually connects the piece that moves these guys is actually snapped, and I can't really fix it without replacing the part. So it's kind of on its last legs, and I just wanted to document it for posterity before I break it down and cannibalize it for its parts. A couple other things. One, it's controlled by this Cypress PSOC. Now, we could have very easily just used an Arduino, but this is what the design called for, and this is what people were familiar with. It really doesn't matter. This thing was not super easy to program, frankly, and it required a level of C that I personally did not have. But again, as a learning experience, that's a good thing, because I had to learn how to program in C much better than I originally was able to. This is the interface. Now I'm going to run this in a second. And again, do not expect to be incredibly impressed by, you know, it's not going to sing you a song or anything. But one of the things I want to point out is that these servo motors do not have any kind of speed control. It's so they move from one position to another at one speed. So the question is, if you have a motor like that, how do you get more gradual or more social movements? So what we ended up doing was writing what is essentially a set of very small incremental movements. So if you kind of think back to your calculus, one way of describing, you know, a curve like that, instead of describing the curve itself, you can describe it by many tiny little rectangles. So that's essentially what we've done with these movements. So instead of one sort of smooth curvy movement, it's actually broken into a very high number of tiny little incremental movements, which you really won't, but it's not jerky at all. You're not going to see that. Another thing I want to point out is that, yeah, you're going to hear this motor snapping back and forth. So the eyelid should be opening and closing at this point, but like I said, that part of the mechanism was broken. So let's see if we can get this guy to run. So you can sort of hear the eyelids, how they should move. Now, so that was full speed, but look at how it's moving slowly at this point. Like I said, the motors themselves are not inherently capable of moving at different speeds. So what you're seeing here is actually just very small incremental movements. And that's really what I was after with this project. Yeah, it's definitely on its last legs, but I just really wanted to document it. So that's really it. Yeah, so that's my first robot. I'm actually pretty proud of it. Many more to come. Thanks for watching.